Welcome to the world of Afrox. Did you know that Afrox is Sub-Saharan Africa's leading supplier of gases and welding products, and that we operate in over 16 African countries with retail outlets and distributors across the continent? Not only do we offer the convenience of in-store over-the-counter products, but we can also deliver orders to your doorstep thanks to our extensive distribution network. Whatever your welding needs, Afrox has the solution. Top-of-the-range, great quality products that you can rely on. Today, we want to take you through the exciting process of gas tungsten arc welding, or more commonly known as TIG welding. This process grants the operator greater control over the weld than competing processes such as gas metal arc and shielded metal arc welding, allowing for stronger, higher quality welds and an improved cosmetic finish. The weld area is protected from atmospheric contamination by an inert shielding gas such as argon, and a filler material is normally used. Now step inside our virtual demo center as we take you through the TIG process and setup. Gas tungsten arc welding, or as it's commonly known, TIG or argon welding, is a welding process that melts and joins metals by superheating an inert gas, resulting in a plasma arc. The plasma arc is heated to temperatures up to 19,500 degrees centigrade. The arc melts the base metal without the tungsten electrode physically touching the base material, and a filler metal is manually fed into the weld pool. TIG can be used on all materials, but is the preferred process for welding aluminum alloys using an alternating current TIG machine. The TIG process requires a DC or an AC/DC constant current power source. The correct power supply is important to determine the correct power source, for example, 220, 380 or 525 volts supply. When selecting a power source for TIG, you will need to consider the application. For example, AC for aluminium or magnesium and DC for most other metal types. In DC mode, ensure that the polarity can be changed to electrode negative, as the torch is connected to the negative terminal and the earth cable to the positive terminal. In DC mode, you need to consider the arc starting method. You have a choice between lift arc and high frequency start. This is critical to consider depending on the application and what percentage of impurities are allowed in the final welded material. The weld procedure would specify the arc starting method. Lift arc and high frequency start is the recommended arc starting methods to ensure that there is no tungsten contamination. When welding aluminium in AC mode, continuous high frequency is required to stabilize the arc, as the arc switches on and off 50 times per second. Ensure that the correct TIG torch is selected for the application at hand. For example, a torch with a hand valve for power sources without a gas control solenoid, or a torch without a valve for power sources with built-in gas control solenoids. Remember to select a water-cooled option for amperages above 200 amps. Also ensure that the correct torch consumables are selected for the application. A sharpened thoriated tungsten for DC applications and a bald zirconiated tungsten for AC applications. You also have a choice of tungsten diameters between 1.2 mm and 4 mm depending on the thickness of the material being welded. The correct filler rod must be selected to match the parent metal. For example, Afrox TIG 70S6 for carbon steel, Afrox TIG 316L for 316L stainless steel, and Afrox TIG 5356 for various aluminium base metals. High purity argon is the shielding gas used for TIG welding. Special mixtures containing argon and helium, for example, are also available for special applications. Remove the cover and blow out any residue that might have accumulated during storage or transport. Connect a flow meter that can provide 8 to 12 liters per minute flow. Connect the gas hose to the gas flow meter and tighten. Set the high purity argon gas flow to approximately 10 liters per minute. Check the hose, flow meter and cylinder valve for leaks. The DC electrode negative process is used for welding steels such as carbon steel, stainless steel and copper. Set the machine to DC electrode negative. Ensure that the arc starting method is set to high frequency start or lift arc. Select the correct size thoriated tungsten electrode for the material thickness to be welded. For example, a 2.4 mm tungsten for a 3 mm weld. The tungsten must be sharpened to 2.5 times the thickness of the tungsten electrode. Ensure that the tungsten grinder is exclusively used for tungsten to avoid any contamination. Select the correct collet and collet body to match the tungsten electrode. For example, 2.4 mm. Screw on the aluminum nozzle. Insert the tungsten into the collet and collet body, allowing for stick out of approximately 5 mm. Now insert and tighten the back cap to secure the tungsten. Set the post flow to 5 seconds to prevent contamination of the tungsten and welded metal during cool down. Connect a remote foot or hand amperage control depending on the application. The foot control is ideal when welding static applications and the hand control when welding in difficult positions. Ensure that the correct filler material is selected to match the base material. For example, TIG 70S6 for carbon steel. The earth clamp must be connected to the workpiece. Set the master amperage on the welding machine. You are now ready to weld. Start the arc and increase the amperage on the machine until the base material starts melting and forming a molten weld pool. Push the molten pool in the direction of the weld while manually adding the filler material to the weld pool. When shutting down the arc, ensure that you keep the torch over the welded area while cooling down to prevent contamination. The AC TIG process is used for welding aluminium and magnesium. Set the machine to AC. Ensure that the arc starting method is set to continuous high frequency. Select the correct size zirconiated tungsten electrode for the material thickness to be welded. For example, a 2.4 mm tungsten for a 3 mm weld. For the assembly of the torch consumables, the same procedures can be followed as DC TIG welding. The tungsten must be bored by setting the machine to electrode positive and initiating an arc until the ball is formed at the end of the tungsten. Remember to set the machine back to AC. Select the correct filler material to match the base material. For example, TIG 5356, which has a 5% magnesium content, or TIG 4043, which has a 5% silicon content. The temperature of the application, required ductility, and cosmetic finish will be used to determine the suitable filler material when welding aluminium. The same welding techniques can be used as with DC TIG welding. You are able to weld all kinds of metals using the different filler metals, and these are available from your local Afrox gas and gear. It does not produce slag or spatter. Produces no fumes or very low fumes. Produces welds of very high quality, especially when high weld integrity is required, for example in the power generation and petrochemical industries. And gives a high quality finished appearance which is suitable for catering and medical equipment. As Africa's leading gases and welding company, we're passionate about welding, and we're here to help you get the best welds possible. Using the Afrox range of welding machines, accessories, consumables, and personal protective gear will ensure that you get the perfect weld every time.